Hi guys, welcome to our video lesson where we're going to continue graphing log functions. So in class, we just got started graphing a couple of our parent log functions, and we're going to do one more of those and then just get into a little bit of transforming. So we're going to graph this function here in letter C, g of x equals the log base the log base 5 of x. So our base is 5. So the reason we need to identify our base is that helps us think about what kind of values we're going to put in to our function here. We want these numbers to be powers of 5. I usually just start off with the reciprocal of that base, which is 1/5, which means the log base 5 of 1/5 would be -1. We're thinking 5 to what power gives me 1/5. Then I think of the next one, which is just 1. 5 to what power gives me 1? That is 0. The first power of 5, 5. So 5 to what power gives me 5? That is 1. Then if I plug 25 in, that would be the second power of 5. And 125 is the third power of 5. So let's graph the points that we can on this standard window. I can graph 1/5 -1. That's just very close to my y-axis. Then the point 1, 0. Then I have 5, 1. And my next point is 25, 2, which I definitely can't graph. So let's go ahead and connect these points, making sure not to cross my y-axis because we know there's an asymptote there, and drawing the curve. Okay, so let's go ahead and draw that asymptote at, remember, it's at x equals 0. And let's fill out this information. Our asymptote is a vertical asymptote at x equals 0. Our domain is all x values greater than 0 because our graph lies completely to the right of that asymptote. Our range is all y values, so -infinity is less than y, which is less than +infinity. Our end behavior, we go as x approaches 0 from the right, our y values are going down to -infinity, and as x approaches infinity, our y values are approaching +infinity. Okay, so that's the last parent graph we're going to do. Now we're going to get into transforming. Now our transformations use the same letters that we always do, which are A, B, H, and K. So I want to highlight those. Remember A right here, that's your vertical stretch or shrink. If that's negative, we're going to reflect over the x-axis. This minus H means right or left. And remember, we always think the opposite. And then this plus K is up or down. Now, because we have our log function now that has a vertical asymptote always, just going to draw a picture of one here. That vertical asymptote is affected if we move right or left. And remember, the H value is what moves us right or left. So the asymptote is always just x equals H. So however we've moved right or left, that's where our asymptote moves. Okay, let's get started. This is a lot like we do our exponentials, just it's a log now. So we have, in letter A, we have g of x equals the log base 2 of x plus 3. So the first thing I'm going to have you do is identify the base, because just like with the parent functions, when we plug values in, we want to think of powers of that base. So we're thinking powers of 2 because that's our base. The only thing that's happened here is we have this plus 3 at the end, which would be our k value because that is not inside parentheses. So I have moved up 3. So because I have not moved right or left, my asymptote has not moved. So my asymptote is still at x equals 0. I'm going to go ahead and graph that. Now, I just need for these graphs a minimum of 2 points. The first point that would be the easiest to find would be just plugging in the value of 1 into our function here, because remember that any base to the power of 0 gives us 1. So I plug 1 in, I'm going to get log base 2 of 1, and then I will add 3. And so what I was saying here is this is 0. So that's just 0 plus 3, which will give me the point 1, 3. Okay, so the 0 power of any base is 1. So 1 is always a good one to plug in. Okay, the first power of our base 2 is 2. So if we plugged 2 in, that would be the log base 2 of 2 plus 3. And the log base 2 of 2 is 1. So this is just 1 plus 3, which is 4. So that's the point 2, 4. Okay, so there are 2 points. Both are kind of close together. I might find another one just for good measure. I mean, base 2 is pretty easy. Like I could plug 4 in and easily evaluate the log base 2 of 4 and then add 3. The log base 2 of 4 is 2. And then if I add 3, I get 5. So that is the point for 5. So there's 3 points. And then remember, our log is a curve. And then it approaches our asymptote there. Okay, the domain, because we have not moved right or left, our asymptote is still at 0, is x values greater than 0. The range is always negative infinity to positive infinity because our y values are infinite. And now our end behavior. As x approaches, now we have to put our value of our asymptote here. It's still at 0, and we're going to put 0 with that little plus sign as a superscript. That means 0 from the right. As I come in toward my asymptote, my y values are going to negative infinity. And then as x approaches positive infinity, my y values are also approaching positive infinity. Okay, we're going to do letter B now. G of x equals 3 times the log base 5 of x. The first thing I'm going to do is identify my base. This is base 5. So I'm going to be thinking of powers of 5 when I plug those in. Transformations, I only have one thing happening. I have a 3 out front. That's a vertical stretch by 3. Okay. So that's all that happened. I did not move right or left, so my asymptote is still at x equals 0. So I'm going to go ahead and graph that. Okie dokie. And now I need a minimum of 2 points. Remember that when we plug 1 into any log, we get out 0. So we could always start there. So g of 1, that would be 3 times the log base 5 of 1. Now, you evaluate the log first. That 3 stays out front. So this is 3 times 0, so you actually get out 0. So that is the point 1, 0. Okay. Let's pick another number. Okay, our base is 5, so why don't we just pick 5? Because 5 to the first is 5. So g of 5. 3 times the log base 5 of 5. So that would be 3, and we evaluate the log base 5 of 5, which is just 1. 3 times 1, 3. So I put in 5, and I got out 3. 5, 3. Okay, let's draw our curve. There we go. Our domain, range, and end behavior is actually the same as letter A, because if you look at it, that vertical stretch didn't change any of these attributes. I still have my asymptote at x equals 0, so my range is greater than x is greater than 0. I'm sorry, my domain. My range is still negative infinity to positive infinity for my y's. I'm still approaching 0 from the right, and I'm going down to negative infinity. And I am going to positive infinity and positive infinity. Okay, you're going to have one more example in the next video.